Hey guys, welcome back to my channel. Continuing with the playlist for IGCSE Edexcel Maths A exam questions for higher. Today we're going to do probability tree diagrams. This topic is most commonly confused, but honestly, it's not that difficult. You need to know two tricks, and if you understand those, you're good to go with this topic. I've already made a video on probability. I've attached the link above for that. You can check that out as well. That's like a different branch of probability. This is a different branch. And if you're someone who's still struggling with preparing for your exam, which is happening in October, November, then do check out this playlist because this playlist has all of the topics that come in the exam. And each video is divided topic wise with exam questions starting from 2018 to 2025. So without further delay, let's start this one and see what probability tree diagrams are about. So it says that Novak is going to play 2 games of tennis. The probability that he wins the first game is 0.7. If he wins the first game, the probability that he wins the second game is 0.9. If he loses the first game, the probability that he wins the second game is 0.4. We have to complete the probability tree diagram first. So as you would know, if the probability of something happening is, let's say, 0.7, like in this case, so the probability of something not happening would be 1 minus 0.7, which is 0.3. So that's why the probability of him losing is 0.3 and winning is 0.7. Now, the question has clearly said that if he wins the first game, so the probability of him winning the second game is 0.9, which means the probability of him losing the second game is 1 minus 0.9, which is 0.1. Then the probability of him losing the first game is 0.3 and then winning the second game is 0.4. So losing the second game would be 1 minus 0.4, which is 0.6. So that's how you complete your probability tree diagram. The sum of the probabilities on branches, they add up to 1. What I mean by that is, if I add these two, this will always add up to 1. If I add these two, this will always add up to 1. Similarly, if I add these two, this will also add up to 1. So the sum of the probabilities coming from the same point, they will always add up to 1. You need to remember this. Without this, you cannot find the remaining probabilities in the probability tree diagram. Then part B says, work out the probability that Novak wins both games of tennis. So if he's winning both games, that means he wins the first game and then he wins the second game. So the reason why I drew these arrows is because you need to understand the path that we're following. He's winning the first game and the second game. So when you're moving along the branches of a probability tree diagram, you multiply the probabilities. If you're moving across the branches, you add the probabilities. In this case, we're moving along the branches. We're going from this branch to this branch, which means to find the probability of him winning both games, we will multiply 0.7 with 0.9, which is going to give us 0.63. Simple as that. First thing, the sum of the probabilities coming from the same point will add up to 1. So 2 branches, the probability on that always adds up to 1. Second point, if you're moving along the branches, you will multiply the probabilities. So for your own understanding, just draw arrows like me so that you know what path you're following. Are you going along the branch or are you going across the branch? Second thing, if you're going across the branches, then you add the probabilities. So 3 main things. If you have these down, this topic will not be difficult for you. Then it says Hector has a bag that contains 12 counters. There are 7 green counters and 5 red counters in the bag. Hector takes at random a counter from the bag. He looks at the counter and puts the counter back into the bag. So it is with replacement. The counter is being put back in the bag. Hector then takes at random a second counter from the bag. He looks at the counter and puts the counter back into the bag again. Now we have to complete the probability tree diagram. So if the probability of getting a green counter is 7 out of 12 and remaining counters are red, so the probability of getting a red counter would be 5 out of 12. There are 5 red counters and 12 counters in total. So 5 out of 12 is the probability of getting a red count. Now the question clearly said that Hector takes out a counter, looks at the color, and then puts it back. So if he's putting it back, that means the total number of counters is not changing. So if the total number of counters aren't changing, that means the probability of getting a red or a green counter in the second try is also going to be the same. So it's going to be 7 out of 12 over here because the number of counters aren't changing. And over here, it's going to be 5 out of 12. As you can see, they already showed that in the second branch as well, that green is 7 out of 12 and red is 5 out of 12. So if you notice these questions and solve a few, you will realize that some of the answers are already given in the questions. You just have to read the question very carefully and identify the information that they're asking for. Then work out the probability that both counters are red. So let's draw the arrows again. We're going from here to here because both counters are supposed to be red. So which means you multiply 5 over 12 with 5 over 12. And that's 25 over 144. We can't simplify it, so it remains as it is. Simplifying isn't necessary every time. In this type of question, simplifying isn't very important. You can even leave it as it is. You'll still get the mark. So then this question says, Megan has a jar containing 15 counters. There are only blue counters, green counters, and red counters in a jar. So we have 3 colors for Megan. Hector is going to take at random one of the counters from his bag of 12 counters. So if you remember, Hector has green and red. He will look at the counter and put the counter back into the bag. Hector is then going to take at random a second counter from his bag. He will look at the counter and put the counter back into the bag. Megan is then going to take at random one of the counters from her jar of counters. She will look at the counter and put the counter back into the jar. The probability that the 3 counters each have a different color is 7 over 24. Work out how many blue counters there are in the jar. So as told in the question, first Hector is taking out 2 counters and then Megan is taking out 1 counter from her jar. So Hector has green and red. So if he takes out a green counter, that's going to be 7 over 12. And if he takes out a red counter, that's 5 over 12. Now, we don't know whether he'll get the green counter first or the red counter first. So which means there are 2 possibilities. He can either have red first or green first or vice versa. So that means there are 2 possibilities for Hector to get a different color each time. So if we simplify this, that's 70 over 144. Now for Megan, she can only take the counter once, and that's after Hector. And the color choice that Megan is left with is blue because Hector is already taking out a green and a red counter. And since we need different colors, so for Megan, the probability of getting a blue counter would be x over 15. Because total number of counters for Megan are 15. And we don't know the number of blue counters, so that's assumed to be x. So for Megan, it's x over 15. We have the probability of the 3 counters being a different color. So 7 over 24 is equal to x over 15 times 70 over 144. 70 over 144 is the probability of Hector taking out the counters, and x over 15 is the probability of Megan taking out a counter. We simplify this, 7 over 24 equals to 70x over 144 times 15. That's 2,116. The 0 gets cancelled out. So 7 times 216 divided by 24 times 7. So the 7 gets cancelled out. And if we do 216 divided by 24, that gives us 9. So the number of blue counters are in the jar are 9. So for these type of questions, you need to remember that there are always several possibilities of a thing happening. If we're taking out a color first and the second color next, the opposite can also happen. The second color will come out first and the other color will come out next. So you have to keep these things in mind and you have to make sure that we're incorporating this in your answer. Because if you don't, then your final answer will be incorrect. There's no one fixed way to do something. There are always different ways present. So you have to make sure that you remember that. This question says each day that Barney goes to college, he either goes by bus or he walks. The probability that Barney will go to college by bus on any day is 0.3. When Barney goes to college by bus, the probability that he will be late is 0.2. When Barney walks to college, the probability that he will be late is 0.1. Complete the probability tree diagram. So the probability of him going by bus is 0.3, which means to walk is going to be 0.7. Then it says the probability that he goes to college by bus and he's late, that's 0.2, which means not being late is going to be 0.8. Then the probability that he walks to college and he's late is 0.1, which means not being late is 0.9. Simple as that. We just subtract the given probabilities from 1 to get the missing probability. Now, Barney will go to college on 200 days next year. Work out an estimate for the number of days Barney will be late for college next year. So he can be late if he goes by a bus, and he can be late if he walks as well. So these are the two parts that we have. So let's first find the probability of him being late each time. So 0.3 times 0.2. Since we're going along the branches, I multiply the probabilities. And now we're going across because now we're moving along the next branch. So now it's plus, then again 0.7 times 0.1. So this is what I was talking about. Along the branches, you multiply the probabilities. Across, you add them. So 0.3 times 0.2, 0.06 plus 0.7 times 0.1. That's going to give you 0.07. Now we add them up, which is 0.13. We have to estimate the number of days he'll be late. So if he's going 200 days, we do 200 times 0.13, which equals 26. So out of the 200 days, he's going to be late for 26 days. Then this question says there are two bags of counters, bag X and bag Y. There are 20 counters in bag X. 11 of the counters are blue and the rest are red. So if the probability of getting the blue count is 11 over 20, probability of getting a red would be 9 over 20. Let's write that first. Then there are 16 counters in bag Y. 9 of the counters are blue and the rest are red. So if we draw the branches in bag Y, there is blue and there is red. Blue and red. So there are 9 blue counters, so 9 out of 16, and the remaining are red. So that's going to be 7 out of 16. So 9 out of 16 and 7 out of 16. These are your probabilities. Annie takes a random account from bag X and takes a counter from bag Y. Complete the probability tree diagram. So based on the given information, this is your probability tree diagram. Work out the probability that the two counters are both red, and then work out the probability that two counters are both red or both blue. So both red is going to be this and this. So both red is 9 over 20 times 7 over 16. That's going to give us 63 over 320. Then both red or blue. So that's going to be 63 over 320 plus, now for blue, that's 11 over 20 times 9 over 16. So that's 63 over 320 plus 99 over 320 That's 162 over 320. That is the probability of getting both red or both blue. So as you can see, the questions are very similar. Nothing odd is happening. Like if you practice like 5, 6 questions, this topic is very easy in scoring for you. Then this question says, here are 9 cards. Each card has either a number on it or a letter on it. Thomas is playing a game. He takes at random one of the cards and keeps it. Keyword that he's keeping it, so it's without replacement. Thomas then takes at random another card and keeps it. Complete the probability tree diagram. So let's see how many numbers do we have. 1 and 2. There are 2 numbers and there are 9 cards in total. So 2 out of 9 is the probability of getting a number. And then 7 out of 9 is the probability of getting a letter. So if he's taking a number, that means there's 1 less number card. So 1, because there are 2 number cards, so if 1 less, so there's 1 remaining. And now the total number of cards is also 1 less, which means 1 over 8 for getting a number in the second card. For the letter, the number of letters is not going to be different. So that's going to be 7. However, the total number of cards is 1 less. So it's 7 over 8 instead of 7 over 9. Once again, if it's without replacement, then the total number of cards is going to change because you've already taken out 1 card from the total cards. So 9 becomes an 8. If you take out a number card, then the number card becomes 1 less. If you take a letter card, then the letter card becomes 1 less. Now over here, if you're taking a letter, number cards are going to be the same, but the total cards are going to be 1 less. And over here, the letter would be 6 out of 8 now. So this is your complete probability tree diagram. Then it says work out the probability that each of the 2 cards has a number on it. So for both numbers, we go from here to here. So that's 2 over 9 times 1 over 8. So 2 over 9 times 1 over 8. 2 ones are 2. This is 4. So that's 1 over 36. That's your probability. Then work out the probability that there will be 1 card with a number on it and 1 card with a letter on it. So 1 card with a letter and 1 with a number. So number first, then letter, or letter first, then number. So that's 2 over 9 times 7 over 8, or, so that means plus 7 over 9 times 2 over 8. So that's 14 over 72 plus 14 over 72, which is 28 over 72. Simplify this, 14 over 36. If we simplify this, that's 7 over 18. So that's the probability of getting a number or a letter. Then this one says Felix has 10 cards. There are 5 red cards, 4 blue cards, and 1 green card. Felix takes at random one of the cards. He does not replace the card. So again, keyword over here, does not replace the card. Felix then takes at random a second card. So that means there is 1 less card in the total number of cards. They have given the probability of getting a red, blue, and green card for the first attempt. Now for the second, if he's not replacing the cards, that means there is 1 less card in the total number of cards. So if he's taking red first, then number of red cards are going to be 4 and the total cards are going to be 9. For blue, the number of cards are going to be the same, but total is less. Same for green, it's 1 over 9. Now if she's taking a blue card, red is going to be 5 over 9, blue is going to be 3 over 9, and green is 1 over 9. Now if she's taking a green card, red is 5 over 9, blue is 4 over 9, and green is going to be 0. Why 0? Because there's only 1 green card. So she's already taken that card. There are no green cards left. So this is your complete probability tree diagram. Now we have to work out the probability that Felix takes at least one blue card and no green card. The question says work out the probability that Felix takes at least one blue card and no green card. So we can have more than one blue card because it says at least one. So that means more than one can happen. And no green. So for no green, he can have a red and a blue because we need at least one blue card. So this is one of the possibilities. Then he can have a blue and a red. He can have a blue and a blue. Then that's it. Because we don't need any green cards. So third branch is already about green, so we can't use that. And over here, wherever there's a green card, we can't use because it says no green card. So it's going to be 5 over 10 times 4 over 9. That is one possibility. Or we have 4 over 10 times 5 over 9. Or we have 4 over 10 times 3 over 9. These are the three possibilities we have where she takes at least one blue card and no green card. So we can have a red card, there's no restriction on that, but we can't pick a green card. So that's 5, 1, 2, 2, 2 over 9, plus again 2 over 9. And then this is going to be 2, 5, 3. So that's 2 over 15. So if we add it up, that's 45, 20 plus 6, 26 over 45. That is the probability of Felix taking at least one blue card and no green card. So that's your final answer. When this question says, Magnus and Gary play 2 games of chess against each other. The probability that Magnus beats Gary in any game is 2 over 9. The probability that any game between Magnus and Gary is drawn is 4 over 9. The result of any game is independent of the result of any of the other games. So if Magnus wins, the probability is 2 over 9. If the game is drawn, that's 4 over 9. And if he loses, that's going to be 3 out of 9. Because if we add these up, that's 6 out of 9. So 1 minus 6 out of 9 is 3 out of 9. Now, the result of any game is independent of the result of any other game. And the probability that any game between Magnus and Gary is drawn, that's 4 out of 9. So first, let's begin with finding the probabilities for the second game. So if the result of any game is independent of the result of any other game, so that means Magnus wins would be 2 over 9, draw would be 4 over 9, and losing would be 3 over 9. So it's the same thing that we're going to write for each branch. So those are your probabilities. Now let's go to part B and see what they're asking us to do in that. It says for each game of chess, the winner gets 2 points and the loser gets 0 points. When the game is drawn, each player gets 1 point. Work out the probability that after 2 games, Magnus and Gary have the same number of points. So to get the same number of points, winner is getting 2, loser is getting 0, and draw is 1. So if he wins, that's 2. If he loses, then Gary gets 2. So 1 win, 1 lose. So that's 2 over 9 times 3 over 9. That is one way. So let's highlight that. Then both can have a draw. So this scoring same points in this case over here. That is another possibility. Then Magnus can lose and Gary can win. So 3 out of 9 and 2 out of 9. So these are the 3 possibilities we have where they score same number of points. Because 1 wins, 1 loses, one wins, the other loses, and then both are draw. So 2 out of 9 times 3 out of 9. In this case, Magnus wins and then Gary wins. Or both are draw in the two games. So that's the other possibility. And then one game Magnus loses and the other Magnus wins. So 3 out of 9 times 2 out of 9. So that's going to be 6 out of 81 plus 16 out of 81 plus again 6 out of 81, which gives us 28 out of 81. That's your answer. Then it says Magnus and Gary now play a third game of chess. Work out the probability that after 3 games, Magnus and Gary have the same number of points. So after the third game, for them to have the same number of points, so let's go back to the probability tree diagram and see how they can have the same number of points after the third game. So same number of points after the third game, which means they can have a win, loss, and a draw. And if there's a draw, then there's a win and loss. And then if there's a loss, then there's a win, and then there's a draw. These are the 3 different ways. So for them to have equal number of points after the third game as well, we can say that Magnus wins first, then Gary wins, and then they have a draw. So there are 3 different ways of having this thing, because Gary can win first, then Magnus can win, and then they can have a draw, or like draw first, then win, then lose. So 3 different ways for this. Other possibility we can have is that all 3 are draw. So if all 3 games are draw, they have equal number of points. Then the third possibility is that, as I was saying, lose, win, draw, or lose, draw, win. So it's again 3 over 9 times 2 over 9, and then there's a draw 4 over 9. So again, 3 possibilities for that as well. Now for the third branch, Magnus can lose, then Magnus can win, and then there's a draw. So again, 3 possibilities for that as well. 3 out of 9 times 2 out of 9 times 4 out of 9, and then times 3. So these are the 3 different ways in which they can have equal number of points after the third game as well. Now let's solve this to find the final answer. So that's 2 times 3 times 4, and again times 3. That's 72 out of 729. Then we have 64 out of 729. And again the same thing, plus 72 out of 729. Add these up. 208 out of 729. This is your probability of them getting equal scores even after 3 games. So with that, we're done with the questions for probability tree diagrams. If you have any questions or confusions, please leave a comment below and I'll help you out. And for someone who understood everything, please like and subscribe. Share this video with your friends, and don't forget to check out this playlist because it has several videos for each topic, and you'll come across several questions which will help you in understanding the paper pattern and avoid making mistakes in your exam.